All right, so let's quickly talk about the session that we have. And I know suddenly you're seeing a different topic altogether. I'll give the context of that, and then we'll go into the details of the whole session. This is a session which is part of my Google I/O talk. I'll share the link of the YouTube. You can go and watch that as well. The session of that sort of was Gemini API from prototype to production, in which we actually build the MRAG system or multimodal RAG system. So of course, in a given time frame, we'll not be able to cover everything in that I covered in that session. But do not worry, I'm going to share the links of the notebooks, the link of the actual talk, and everything for you to go in detail. But essentially, that session talked about how you can go from Google for AI developers Gemini API to Google Cloud Vertex AI Gemini API. I know it sounds sort of confusing. Why do we have two API? But bear with me. We'll talk about all of this quickly. Couple of things from a session perspective is that I'll probably take questions towards the end. If there's anything which is pressing, I have visibility into the chat. So if you put something there, I should be able to address it right then and there itself if there's anything pressing. If not, please write down your questions. We'll have good enough time towards the end to address those, and I'm happy to sort of stay a little more after the session if you have a bit more details and questions around things, right? So with that, let's start. The way I would want to go about this is I want to sort of start with a storyline or a common scenario that most of us face when we're trying to develop something, and this is essentially a part of the whole process, so that it's easy for us to understand why would you do certain things the way we would want to do. So we start with a simple prototype, and this is again something which is very common when we try to build something in our organizations. We're always, and this is very true in the area of AI ML or Gen AI now, that you don't start with a production system right away, right? You start building things from a prototype perspective. Um, and then once that gets validated, you move to the production side of things. So that's the storyline that we'll try to see. How do we go from that prototype to the production? Now let's understand the problem, which is very important because that's the kind of multimodal RAG that we'll build towards the end. So the problem statement here is that we are trying to sort of build a system which will reduce the research time and of course the cost of the financial analyst. Now, if you know what financial analysts do, or even if you don't know, it's pretty much simple, which is they do a lot of research on a given company, right? So, for example, if they are like, hey, I want to know a lot of things about Alphabet, which is the parent company of Google, and I want to know a lot of different things around that. Now, people have been doing this, and it's quite easy nowadays with LLM to sort of send a PDF, which is, let's say, an annual report or a quarterly report, and you can sort of ask questions to it directly with a simple RAG. What we are going to sort of solve for is that is good, but can we also ask questions to, let's say, audios? Because you can imagine that every company has a earning call that happens every quarter, and we may want to see whether we can actually get question answers through the audio call as well or not. And same thing goes with videos, which is they do a lot of product launches. Let's say, Google does a lot of product launches. There's so many videos on the YouTube and so on and so forth. So essentially, the problem statement here is that we want to do something which is question answering system or something like a RAG, but we want to sort of leverage two very important capabilities of Gemini. One, which is the 2 million context window that we have now. And we'll see how that becomes very important. And the second is that the complex reasonings that you can do with multimodal data. So you can send images, you can send videos, audios, and you can actually ask questions because Gemini is trained to do that, and it's multimodal by default. So essentially, the flow of that looks like this, which is at least from a prototype perspective, and that's what the first part that we want to cover, which is that we should be able to pass a specific document. And this is very important. This flow is important because in the production, we'll change this flow, right? So from a prototype perspective, the flow is pretty simple. You have a document, or let's say a video, or a earning call, or a podcast, or maybe an image. You may want to ask questions like these, like what was the revenue in last 3 quarters, or what was the analyst question asked to the leadership team. This is a very earning call specific questions. Or how is X product going to change, and what are the major features. So let's say Google did some product launch, and you may want to know, you don't want to spend too much time going through so many videos. You just want to get this answer, which is, hey, what is Gemini and what is different features of Gemini? And you get the answers to it. And that's pretty much what we have as the expected sort of flow for it. Now, I'm going to stop here and I'm going to go to the code. Now, let me sort of quickly share this with all of you. All the codes that we're going to do is available here on this GitHub. So you should be able to check each and every code that I'm walking you through. So it has three specific notebooks. One is the GAI, the second is VAI, and the third is VAI in production. So the MRAG is the last one, which is the production one, which is what you have to see if you want to do the MRAG. The first notebook I'm going to skip because it shows the same process of doing simple prototype, but you can use Google AI for developers with this. The reason I want to skip, and this is where I said that we'll focus more on the Google Cloud side of the things, because it's important that we in a given time we do that. But because I'm going to share the overall YouTube link with you, you can actually go through that. But the first two notebooks are pretty same. It's just that we do use two different ecosystems. So I'm going to go to the second notebook again in the link that I shared. This is VAI notebook that I'm going through. Okay, so the problem statement that we were trying to solve was, if I have a document, can I ask a question? If I have a video, can I ask a question? So what we do typically is we quickly install the SDK, we restart the system, we set up our specific authentication. So in this case, you want to sort of do the authentication with Google Cloud. So it gives you access, and then you define your project ID. This is again very important when you're working with Google Cloud. And once you do that, you basically initialize the Vertex. So again, Gemini API in Google Cloud is part of the Vertex AI ecosystem, which is the whole AIML packaging that we have as part of the cloud. So you do the initialization. This sort of establishes a connection, a secure connection with your project inside Google Colab. And I'm using the Google Colab, which is outside of the Google Cloud. There's one which is Colab Enterprise, which is the inside of the Google Cloud. So once I do that, you essentially sort of again do a very basic import around this, and then there's a bunch of details that I've given. There are especially two models that we have, and I'm going to show you a couple of examples of each one of it. So one is the Gemini 1.5 Flash. I'm not going to talk about the older models, which is 1.0 specifically in this. So we'll focus only on the 1.5 Flash and all. I have given links to the documentation, and you should always refer to the latest information. This is just a snapshot, which is in the last couple of weeks. Things change in terms of pricing, in terms of a lot of different things which are supported, in terms of whether they are GA or not. So that's why I've given a link. Please always go through those links and see what is the latest. The 1.5 Flash and 1.5 Pro, these are two models that we have. It's important for us to understand the difference between both. So 1.5 Flash is a model which has capabilities similar to 1.5. So they both are multimodal. However, 1.5 Flash is built for faster inference. So if your use case has anything to do with, let's say, you want the answers to be pretty fast, you would prefer using 1.5 Flash versus the 1.5 Pro. 1.5 Pro can handle complex reasoning, and that's why the latencies are slightly higher. Now, the accuracy is a very relative term, so they're both pretty accurate. But what we suggest always from a Google Cloud perspective and Google perspective is that if you're trying to do any complex reasoning among the text or among the different modalities, prefer 1.5 Pro. But then you have to let go of the latency in that sense. But if you're trying to do something which is not too complex, and it's sort of slightly complex, and it's pretty easy in terms of the capabilities of LLM, but for you it's very important to get the answers quickly, you would prefer using 1.5 Flash. So this is the bit of information that you need to keep in mind. One thing to know, again, this is where I said that you need to be very aware of the versions. What are the discontinuation dates? What's the exact naming of the model that you need to call? So I've given all of these details in the notebook, so you should be able to sort of refer to all the links in that sense. Now, again, both the model works with text, code, images, videos, with or without audio. The only difference is twofold. One, which I have already explained a moment before, which is one is very fast in inference and the other is slightly slow, and you let go of the complex reasoning with the other. The second difference is and this is a difference as of now as I speak. It could change in coming weeks and coming months, which is the support of the context. So if you're using 1.5 Pro, you have support of 2 million input context. This is not output. The output is still capped at roughly 8K tokens. And if you were to use Flash, you have currently 1 million input context, which is allowed, right? So once we understand the difference, the next thing that we do is we sort of do a very basic setup of the API. So we define the methods, we define the configuration. So I'm keeping most of the things default. This is again, you can experiment and play with these configurations, temperatures, and output token. This is the max output token that it can support right now. But again, like I said,
This
things
means
might
that
change
token had
in the
been
coming
supported,
future.
but context window size is like 1 million tokens.
I
Gemini
think
Pro.
somebody is not muted. Okay, perfect. Thanks. The next thing that we do is we set the safety settings. This is again a very important part of the API and also part of how we look into GenAI, which is from a responsible perspective. These are filters which you can control to a larger extent at your end. And if you wish to sort of block certain things while somebody is using your systems, you can sort of define such things at this end. Again, you don't have complete control. There are still certain filters that will be tripped, irrespective whether you set at a very low threshold. But there's a way where you can get rid of those as well, and you can refer to the documentation for more details in that case. Then what we do is we simply sort of define these two models. So one of them is model and the other one is model flash. Again, two different models, 1.5 and 1.5 flash. And the very simple way to sort of get the answers out of these model is that you send a prompt, whatever that prompt is, and then you simply get the response from the model. And with each execution, you can actually see the wall time, which is essentially how much time the model has taken, which is in this case, this is a 6.79 second, asking a very simple prompt. In a lot of other cases, it might actually be higher. So you can see how going from 1.5 model, so this is 1.5 Pro, to going in the flash direction, you can see how the time sort of suddenly reduced to 3.7 seconds, right? So this is pretty much the difference that you'll keep observing again and again, that flash is very faster. And if you're doing something which is not very, very complex, you would prefer using flash most of the time. In the response object, there's a lot of things that you get. So you get the text of actual response, but you also get finish reason, which is if there's something that tripped, you also get to know why it got tripped or why it got stopped. You also get the safety rating of overall output that comes out. So again, this sort of helps you coordinate how and where you want to see the outputs and which kind of things you would want to block. So that's it. And then you also get the usage metadata in the response, which is, and again, this is very important because when you're working with these models, these are again models where you have to do the payment at some point. So it's always better to sort of keep in mind the amount of tokens you're sending, the amount of tokens that is coming out, so that you know how much billing that you can expect at the end of the day. You can also sort of stream the output. So you can see here, I'm very simply sort of sending the same thing, but this time I'm doing the stream true. This is again in those cases where you do not want to wait even for, let's say, 5 seconds or 7 seconds. You just want to start streaming the output as and when they are ready. So this sort of really helps in case where you even want to sort of just keep pushing the outputs. The other thing which is very important as part of the API, and this is what I was telling you, is that not only you get the token count and everything as part of the response, but you can explicitly measure them even before doing anything with them, right? So in this case, you can see that I'm actually counting the prompt token, prompt character count. One thing to note is that the way the billing happens in Google Cloud is different from the way billing happens in Google for AI developers. In the cloud, essentially you get sort of character-wise billing. And sorry, actually both of them are similar. But sorry, the thing that you need to keep in mind is many other LLM vendors, they charge by tokens. That is slightly different in the Google's case. We charge by character, so you should be actually counting the characters that we send. It becomes, we think that this is much easier than counting the token, because token is always going to change with the model that you use. So it's easier if you were to just always count the characters. And that's why you can actually count the character tokens before characters before sending it to this. The other thing to keep in mind is that you have two different pricing tiers. This is very important from an optimization perspective, that the pricings are sort of slightly higher when you go beyond 128 context. But if you keep everything less than 128K, you're not going to be charged at high level for not using 2 million or 1 million. Which is again, a lot of time developers ask, like, do we have to use 2 million? You don't, if you don't have a use case that sort of goes in that direction. So that's how you use that. Now, once we have seen the basic of API, let's now jump into the prototype that we were saying. So again, the goal here is that, and we'll go to the automation of this, that how do we do the production automation and how do we build this as a MRAG tool. Or when I say MRAG, I mean multimodal RAG. But right now, what you're trying to see is whether Gemini can handle this at all at the first level. So what I do here is I have a couple of documents. These documents are public. So if you just click on these links, you should be able to open these documents. So the first document is a simple blog that I have, which is a Google Cloud TPU blog. I'm sort of extracting all the strings from this, and you can see that how those strings are being extracted. This is just a simple PDF parser, and this is how it looks. So just a small text coming out of it. What I do next is, again, very simple prompting. I send the PDF context, so whatever I have extracted in the previous case, and then I have a question, and I simply ask the question saying, hey, what are the key achievements for Google Cloud from the question blog mentioned in bullet? Now, because we're printing all of this, so now you can very clearly see that you get the total tokens, you also get the billable characters. This is where you can see that you'll be charged less than 128K. Why? Because you're only processing 17,000 characters at this point. So you can see that this blog is really huge. And the amount of time it took to respond, and this is Gemini 1.5 Pro, is 10 seconds. So it was able to go through these 17,000 text and characters, and then it was able to sort of answer back the question that you asked. So at least the first part is validated, that okay, if I were to send, let's say, a whole document, it's very easy in Gemini to sort of get me the answer. So this is good. Like, this is what we wanted, right? So no more, you don't have to do, if you have bunch of documents which are like 5 or 6 documents, you don't have to do RAG. You can just send these documents, ask your questions, and you'll be done with it. This doesn't mean, and I want to be very clear with this before, which is just because we have 1 million, 2 million, doesn't mean that we don't need RAG. You would still need RAG, and we'll come to that part very soon. But if you have handful of documents, it's quite easy to sort of do that. So the same thing I do with Flash. This time you can see that Flash took 3.56 seconds, and I was not asking a very complex questions, even though I'm sending a lot of data. And this is where I said that while it may look that, oh, fast means bad performance, that's not the case, right? You can see this very clearly here, which is it took half of the time that it took with 1.5, and it gave exactly pretty much the same answer with slight difference in terms of the formatting. But the answer is pretty much the same in both the cases, right? Because we are asking a very simple, straightforward question. So these are some of those examples where you would say, hey, why should I even bother using 1.5 Pro when I can get the same answer in the half of the time in that case? The next one is a similar example, but this time we're trying to push the envelope. We are saying, hey, why only ask a simple question when I can ask multiple questions and see whether Gemini can sort of answer these things properly? So same thing, you do exactly the same as previous. You again extract all the text. This time you can see that our characters have increased to 29,000, because this is a different document, right? This is a 15-page document. It's not the same document as before, and we are asking 5 questions this time. Again, if you notice, it took 10 seconds with 1.5 Pro, and you can see all of these things is answered properly. And again, I have checked them manually. Feel free to sort of check them manually, and if you find any bugs or any issues, do let us know in the issue tab in the GitHub. But this is a pretty good answer, right? And you can do the same thing with Flash. Oh, in fact, I'm actually doing this with Flash. I'm not doing this with 1.5. So you can see that it was able to process 15 pages, 29,000 characters, roughly 30,000 characters in just 10 seconds and find the answer that you were looking forward to. All right. So we are pretty happy that, we can send a document and we can pretty easily get to the point where we can get the answers or something like needle in the haystack. But how about audio, right? So we said, hey, we should also be able to send a earning call. So again, I'm using GCS, which is Google Cloud Storage Bucket. There's a file which is there, which is Alphabet 2023 quarter four earning, and I've just downloaded the whole file. I send this, and one of the interesting things that I'm doing here is I'm asking again a very specific question. I'm saying, what are the major comments by Sundar and Ruth about AI? You can see that I'm not even defining their full names, right? Because I'm like, the model should know who are these people, and it should be able to establish that relationship with what I'm trying to ask, and it does. And again, you can see that it actually took a bit more time. This is, I'm using 1.5 Pro. This time it took 1 minute 29 seconds, because this is a 1 hour audio. So 1 hour audio, as you can imagine, is a huge, and this is where we are seeing the capability of that 2 million context window in the case of 1.5 Pro. And you can see very clearly that it was able to identify that, oh, I'm talking about Sundar Pichai, and it quickly summarizes what were the main things that he said, what are the main things Ruth said. And then I asked a very specific question. This is more like a compound question, that what were the analyst questions, and give their names. So it was able to figure the names of those persons, and also the company. So Morgan Stanley, Brian asked these questions. Doug Amorth from JP Morgan asked these questions. So it was able to sort of give this thing amazingly well. But again, you can see that this took some time, because this is the complex reasoning part. You're asking a very compounded question, the input is the audio, and so on and so forth. Now, I'll do the same thing with Flash, and this time you can see that how the time has reduced tremendously to 36.4 seconds. And again, you pretty much get the same answer, right? So this is again one of those areas where, while it looks very complex, but Flash sort of does amazingly well. Maybe it's not as comprehensive as the 1.5 Pro. And this is something very subjective, that as a business owner, you get to decide, like, whether you would prefer doing something comprehensive, or whether you would prefer something which is fast and gives you pretty much the bullet points of the whole conversation. Okay, so the audio is also validated. Let's see the third part, which is, how about I was able to extract, and I'm taking the same TPU blog thing this time again from GCS. But the problem is, I was not able to consider the images, graphs, and so many things, tables, and all of those things in the previous case, because I was um, just extracting the text out of it, right? So you lose so much of the context which are available in the images and all of those things. Now, what I do here is I do something very simple. This time I'm not extracting text. However, I'm using part dot from URI, and I'm defining the MIME type application PDF. So even in the previous cases, if you notice, when we were sending the audio, we were sending the audio in the same way, where we defined the GCS URI, and the MIME type was audio MPG. This time the MIME type is application PDF. This is important because this time the backend logic will take each page as an image. So it is not extracting any text. It is essentially considering each page of the document as an image itself. And because of the image capability of Gemini, you can actually ask the questions from the images directly just by using a simple feature in the Gemini. So if you see this question, what is the EMFU for BF16? And this is a question, again, this is the question I came up with, which is available in one of the tables. So if you actually open this file, you will see that this question that I'm asking is available in the table, which I would never be able to get in the previous case if I just extract the numbers. And I'm also asking it to cite the table and the page number. And you can see that it goes through. Again, I'm using the 1.5, and it goes and sort of gives me the exact number from the page, and it tells me how much EMFU it was able to achieve in 56.06%, right? So again, if you go and check the document, you'll see this is the exact same thing it has used, and this is just a blog that we have done. So Again, if you have any PDF where there's bunch of different graphs and charts and tables and all, try to use application PDF, and you should be able to consider all of those as context as well. It took 7.4 seconds before, and when you use Flash, it uses 3.56. And again, it pretty much gives the same answer. You can see this is one of those value extraction. Both of them are giving 56.06. The difference is how they represent the answer, how much detail it goes in the answer. So again, it's a very subjective choice whether you would prefer this over the other, and you're okay at the cost of the time. The last example I want to talk about is the video. So just like in the similar fashion of PDF and the audio, you can also do video. So if you see this example, I have a video which I downloaded from YouTube, which talks about what is the next Google search iteration, leveraging AI. This was a video that was published in Google I/O 2023. And again, I have questions around it, right? This is exactly the same question that we saw in the presentation, which is describe this video and how is Google using generative AI in search, give responses in bullet. So again, you can see that it was able to sort of figure out how many token count that I was sending. One thing to remember is that when you do this token count before, it'll not sort of consider the video, but when you sort of do this after, it'll consider the video, and your token count are slightly calculated different in the case of audio, video, and images. So again, I've given enough links for you to see how those calculations are done so that you're always aware of how the billing happens, and you should be very careful with all of those things, right? So you can see that I'm essentially doing 27,000. And again, this is like a 5 minute of video. And it was able to sort of go through the video. In 19 seconds, it was able to give me what the video is. And again, and sort of tell me what these things are, and the question that I asked in bullet. Okay, the next quick thing that I want to show you is the context caching. This is again one of the most widely requested feature. And I'm going to take a quick pause right after this notebook before we go to the next one, the MRAG one, just to address some of the questions. The context caching is essentially, and a lot of time people ask that, hey, 2 million and 1 million is good, but what if I want to sort of, because right now, if you were to ask this question, let's say every day using the same input source, let's say that's a 1 hour audio call, you would have to constantly keep sending that audio again and again, again and again, whenever you have to ask that question. Now, of course, that takes time. The second thing is it also sort of adds to the cost of reusing the model again and again, right? So the way to address this is context caching, where you can actually take the context that you have, and the context could be video, audio, big files, big PDFs, and everything. And then you can just keep a cached version of it. And I've shown how to do that. You can sort of just create a cache of whatever you're trying to do. So in this case, I'm taking the same MP4 and I'm caching it. What this does is next time when you have to ask the question, you can just load the model from the cache. So you can see I'm loading the model, I'm loading that cache, and I'm asking the same question one more time. So the next time, the answers will be pretty fast because it doesn't have to do all the context processing and all. And the cost is slightly different. It is not no cost, but the cost is slightly different. And I've given links where you can actually see the pricing for that as well and get the more details around it. And you can see that now I don't have to sort of send the context again and again. I can keep asking questions. So the second thing I'm asking again, it has the ability to sort of transcript your audios as well. As you can see that it goes into details and sort of gives me all of those things. The last thing I want to mention before we jump to the MRAG and we'll take a quick break to address question is the embeddings. Vertex and both Google for AI has text embeddings, which is one of the latest model that we have, which is 004. What this does is it whenever you have a text, it gives you the embeddings. Now I can have a whole session just about embeddings, but what you need to know right now is that embeddings are important because that translates text into bunch of numbers. These numbers help you find similar things between the text. So if you have, let's say, two text, or let's say you have one document and you're trying to find a similar document which talks about the same thing. And when I say similar, it doesn't mean word similarity, it means semantic similar. Are they talking about the same thing? When you have to do certain things like that, you need embeddings to be part of it, and that's what text embedding 004. Vertex goes one step beyond because it also has something which we call as multimodal embedding. What this means is that you can also embed, let's say, a image and a video, and you can also create embeddings around it. This is really powerful. I would request all of you to sort of explore this and see the kind of things that you can build, because with this, you can build search engines which can search for similar images, it can search for similar videos, and the use cases are sort of infinite if you play with this. So do explore this. It's really powerful. But this is all what we need to know before we jump into the multimodal tag. Now, with that, let me take a quick pause and let's see if we can address some of the questions. I'll take some because I can see there are a lot of questions, but I'm going to take um, some which I think are important. Let's see. So I think GitHub link is sorted. How come tuning is not available? Tuning is available. I am not showing it right now. So if you go to both the areas, you should be able to see the tuning, which is this. Perhaps except the Vertex AI embeddings can the same code, sorry, can the same code run in the Google AI Studio? Yes, absolutely. And Yuri, if you want to sort of see, please refer to notebook one, which is GAI, which is everything that I just showed you, but how would you do that same thing in Google AI from an API perspective? On the studio, you anyway can do this. You just have to upload the document and ask the question. This is more from an API perspective, but you're right. You can actually do this in either of the ecosystem. Um, yes, I downloaded the video from YouTube. 2 hours of video. The video that I'm using currently is not 2 hours. It's like 5 minutes. So this is one. How can we control the hallucination in this model? Correct and update from the document. We'll cover this, Ajendra. If you don't get the answer, please ask this question one more time towards the end. I will not take any pre-trained open source. Okay, so I think I've given I've addressed most of the things. Okay, let's jump to the next one. All right. So once you have done the validation, the next thing that we need to talk about is that, and this is again from a high level perspective, do remember there's a slight difference between both the APIs. Again, Google for AI Developers API, which is roughly what you all know as Google AI Studio, and the Vertex AI. There's just three level difference. One is the installation, the dependencies, and the authentication. This is what you need to change between both the platforms. Rest, most of the things remain pretty much similar. So whatever code bases that you develop, if you ever want to move to the other side, you have a very easy way to sort of do that, right? So just keep this in mind. This is very important to remember. All right. Now let's talk about what is the production path and how do we do the multimodal RAG aspect of it, right? So on the left, what you saw was we were trying to solve the problem, but one of the big thing is that we actually used to give the source document, right? So again, if you see most of the examples, you were actually giving the documents and then asking the question, and that's what the left side of the picture tells you. What we want to be able to do is slightly much automated and slightly more intelligent, which is if you give a question, you should not give the document, right? Because again, if you think from a production perspective or how this will be leveraged um, at the other side, this will never look like where the analyst is always sending the document. Uh, and again, they can do this. They can just use Google AI Studio and send the documents and ask the question. But when they are trying to do this in a very comprehensive and large scale level, they would want some kind of an intelligence layer where they just ask the question. The intelligence layer, by using the magic of Gemini and embeddings, should be able to find which sources of documents have that information. And then those relevant documents are fed to Gemini, and then Gemini again frames back your answer. Now, this looks very similar to how RAG in general works, where it automatically figures out where the context is. One slight change from that perspective is that this time we will also know which documents, as in video, audio, will also be part of the context. So that's why we call this as multimodal RAG, because this time you're not only finding some text, but you're finding which document do we have. And it's a very simple process of how we do that. So let's get to that notebook, and let's try and understand what we can achieve with this. So again, this is the third notebook. The link that you all have in this, the third notebook, is the multimodal RAG notebook. Before I start, I want to quickly show you what is the end state. The end state is exactly just like we saw in the diagram, which is, if I were to ask a question, I don't care where the answer is available. I don't want to attach the document. It should be able to figure this out automatically and give me the answer and the explanations that I have. And you can see that it should also tell me the source behind it. So you can see that it tells me, hey, I picked this answer from this specific blog. And because you also have the indexes available, you can also see the pages from where it is picking this. This also sort of addresses one of the questions which somebody was asking, that how do you control the hallucination? So this is one of the ways you control the hallucination. You're not relying on the model's capacity to answer this. You're saying, hey, I'm giving you the context. Always get me the answer from that and give me the source and the citation of it. So this is the end state that we are trying to do, right? So we go through the standard things which I showed you in the last. We need to do a bit of pre-processing before we can reach. Now, to show that, I'm going to show you a good diagram that sort of covers the whole thing that we'll do, and we'll go from left to right. This is the indexing that we are doing. Let me sort of zoom this up, and let's go from the left to the right. So let's imagine that we have unstructured data. This includes PDF, TXT files, audio files, video files, images. So this is what we have on the left side. All of this is stored in a GCS bucket. And again, this is happening because we want this to be secure, right? Now, once we have that, we do specific pre-processing. The first one is with the text data, so both the PDF and the text file. We do 4 levels of extraction. So we extract the normal text, we extract the charts and the graphs, we also extract the tables and the images that we have. And then we again keep all of them in a simple data frame. Just to show you, if you see, this is what we are doing here. Again, in this diagram, you can see that I have a text, I have a GCS path, I have a page number, and I'm extracting the raw text here, right? And this is how the data looks like in that case. So we have the metadata as well. So we have the GCS path, we have the page number, and all the different things that are available. We extract them one by one, and we keep it in the same data frame. The second thing that we do is with the video. So what we do is we again use Gemini, and you can use both. You can use 1.5 as well as 1.5 Flash. What we do here is we ask Gemini that, hey, given this video, can you do the transcript and the summary? So that's what you see in the next step. And again, the production data in this case is very different. So this time um, we're not using one file or two file. As you can see that I'm actually using so many different files, and each file has so many different pages, right? So this time we are really serious about doing the search across so many different documents of videos and audios. So that's how many PDFs that I'm processing. And this is how sort of each page looks like. The second thing is I am doing this with the audio. So you can see that I'm processing again bunch of audios. I have both earning calls and I have some podcasts. Again, Google podcasts where they're talking about different things. I do the whole processing. I use Flash in this case, and this is what we are showing here, right? We have a source video, the audio, and you get the transcript and the summary out of it. And just to show you how that looks like, let's see one example, right? So you can see that total files that I process is close to 18. And this is how one of the audio description looks, right? So again, our goal is not to find exact quote in the first half. Our goal is to just know whether the question that I'm asking is available in this audio or not. So you can see that I'm doing a thematic analysis of the audio, and I'm also getting sort of summary of different segments. So the first 4 minute has a summary this, the contextual this, and again there's a prompt that I have written to get this. So you can actually see the prompt, and you can change the prompt according to what you want to do. So this gives you a very detailed analysis of the whole audio. As you can see, it goes through all the segments across 24 minutes. And for each segment, it sort of gives you that analysis. Same thing it does with video. Again, you can see the prompt, and you can see that it processed close to 18 files. And this is how the video analysis looks like, right? again goes through different segments. It sort of also has different elements that it extracts and all of those things. So this is what is happening on the left side. So what we did in the first part of the indexing is we took all the unstructured data with the help of Gemini and different parsers, which are available in Python. You were able to build a structured data out of it, which is from unstructured to structured. Now, everything that you have has a couple of things. One, everything is represented as text. So if I were to show you how every data looks like, you can see each data frame is now the GCS path, the type of the video. So I'm essentially maintaining that metadata that, hey, this is a product launch video, and we have the description of it. So what we have now is the metadata, and this is important because we want to reduce the hallucination. We want to make sure that everything gets cited, everything gets properly executed in that way, right? So this is the first half of the problem that we have done. The second half of the problem statement from an indexing perspective is that now that I have all of this, let me sort of jump to that part of the code. You can see that I have all of these different data frames. I have text, I have video, and I have audio. So I have three different data sets. What I want to now do is build a common index so that I can go back to the source of the file, right? To do that, the first thing I need to do is I need to first chunk all the text into smaller quantities. Now, this is important because we're not trying to. There's no point because users are going to ask a question, which is, let's say, one question or a two question, right? You don't want to match it across the whole summary or let's say the whole page. You may want to measure it with the smaller chunk from the text. So that is the next step. What we are doing, we are chunking all of this, and then we are taking different chunks, and then from each chunk, this is where we saw the examples of embeddings. We put all of these things into embeddings, right? All of these embeddings are created, and the way this looks towards the end, let me sort of show you, is that I create all of these embeddings and the final data for each individual one. So this is for the text. So you can see how comprehensive we are maintaining the metadata. So we have the blog post, we have the GCS path. So we know what the text type is, we know what the GCS path is, where the original file is, we know the page number, we know the actual text, we know the embedding, and we have a specific index to reach to this level, right? And if you see the index essentially tells you that, oh, this is page number 2 of the blog post, and we know that the source here is text based. So like this, we have the similar thing for video. Same thing, you have the GCS, you have the embeddings, we have the and again, in this case, the embedding is of the description, not of the video. So it's not a multimodal embedding. This is a text embedding that we have, and we have the same index here so that we can come back to this index at the later point. And same with the audio. And then what we do is we sort of just take the last two columns for each of the three data frames that we have, and then we create the final index database where you have the index, you have the source. Now, this is important because when the user sends you, uh, uh, whenever the user sends you query, all you have to do is you have to find among these different embeddings, which are the top 5 embeddings which are closest to it. For each of those 5, you look into the index and you exactly get what those files are, and you can always take that and send it back to the Gemini. So this ends the pre-index step. So this is all what we're doing in the pre-indexing step for us to do the multimodal RAG. Now let's do the retrieval and the generation step, right? And again, all of this, none of this is using either the LangChain or Llama Index. You're free to use either of those open source tools if you wish to. This is more from a foundational perspective. Like, what is the theory behind doing all of this? You don't have to write the way I did. You can actually use LangChain and Llama Index if you wish to. But this is if you're trying to learn how to do these things, it'll be very helpful if you go sort of step by step and code by code in that way. This is very similar to how you can use Keras to do convolution neural net, or you can sort of write everything from scratch and learn how each and every layer works. So this is that kind of a thing. So next is the retrieval and the generation. So let's quickly see how that sort of works, right? So to show that, and again, there's a whole code on this. So let's quickly see how that works.
It seems Lavi is having some audio issue. Am I audible to you all? All right. Thank you for your confirmation. So let's wait for a few minutes. I hope everybody is enjoying the session. So ask as many questions as you want to clear your doubts and get most out of it.
Oh, sorry. Did I disconnect from the meeting?
Yes, Lavi, you got disconnected. Your audio was like we were unable to hear you. Now
Okay.
it's
Oh, sorry.
perfect. Yeah.
How much time did I lose because I was just speaking?
No,
Is it 5 minutes?
no, no. Yeah, hardly last 1 or 2 minutes.
Oh, okay. Okay. I'll go back
Yeah.
to the diagram. I'm just gonna close in next couple of minutes, and then I'll take the questions if everyone is ready. Is the screen visible?
Yes.
All right. So, sorry. Like I said, I have troubles with the internet. Okay, so let's talk about this whole for one more time. You already understood the whole process that we did with the batch indexing. This time we are going through the last stage, which is the retrieval and the generation. So what we do here is, let's say you ask a question. What we do first is we go to the index DB. Again, the index DB that we were creating here. We go to this and we say, hey, and we run a simple cosine similarity and say, can you please give me the top five embeddings which are sort of close to the question that the user asks? And what it does is it gives you those five indexes which are close to it. What we then do is very simple. We say, okay, because Gemini has 1 million and 2 million context window, I don't need to send only the text. And this is very important for all of you to understand. This is minute change in the way RAG works, right? So if you see on the right, the RAG template typically means that you have RAG instructions, you have question, and then you have context. In the context, in a typical RAG, you send those text as a context, right? But this time we are saying, no. Let's not do that because we know Gemini has two very important capabilities. One, it can do 2 million, which means I can send a lot of context. And second, it can do complex reasonings among the different modalities of the data. So what I do in the previous stage is, rather than sending the description, transcriptions, and the raw text, I say, no. Just tell me which of the pages and which of the audio or the video or the image you think my information is available. I'm just going to take those and send it as the context in the next stage. So, for example, let's say it figured out, oh, what you're looking forward to is available in this audio, in this video, in this PDF on page number this and that. So I only take those specific pages from that PDF, not the whole PDF, and I attach the whole audio video as it is in the RAG prompt. And we can do that because we saw that example previously, right? You can send the video and you get the answers out of it. But the good thing this time is it's not you who is doing it. It's essentially the combination of embeddings and the indexing that we have done, which was able to do this automatically. So once I have the top five, I essentially send all of this as context, ask Gemini that, hey, now can you answer the question now that you have the source files, which contains the actual answer that I'm looking forward to. And it does this brilliantly, and you finally get the answer without you even knowing where the answer is available. So now when we go back, and you see, when I ask this question and run my get answer function, which essentially does exactly the same thing or the same flow that I walked you through, and I'm saying just pick the top five relevant indexes, and then just take those files and give me the answer. And you can see how beautifully it went through the question that you asked. It broke it down into two questions and it gave the final answer along with the citation. So you can see that it gives me the source saying, hey, I found this answer in a podcast in the episode 6 MP3. The second one it found in the podcast, again, episode 6, and it also found this in a different audio, which is safety and responsibility. Oh, sorry, in the video where it was safety and responsibility with AI. So this is really brilliant if you think about it, right? Because this is how humans work. This is how humans are able to figure out and say, oh yeah, I know, I saw somebody saying this in an audio, and I saw somebody in the video saying this, and it was able to reason across those things. And the most important thing is this time we're not sending anything. We are sending is a query, and it gives us the answer with the citation. And the citation is happening because you're explicitly maintaining the metadata all across. You're maintaining the type, you're maintaining the GCS location, so it knows where those indexes are. Now, I'm going to show you both the answers. I'm going to show you how you can get the Gemini Pro to work on this. It took 51.9 seconds to process those different videos, audios, and do your answer. Oh, sorry, this 51-second includes this process of figuring out the top five and then sending to Gemini and getting the answer. So this includes that time. So it's not just the model time, but it includes that search as well. Similarly, if you were to do Gemini 1.5 Flash, it took 43 seconds. Now, let me show you this part, which is what was Gemini seeing towards the end, or what is that I was sending to Gemini through that code block. So you can see first one is essentially the instruction of the RAG, then the questions, and then see the contextual file. So it's taking the MP3, bunch of MP3, bunch of audio, and bunch of videos. And it figured this out. If I actually print the citation, this is what I was showing you. This is the top five of those citation along with the scores, which had the information that we were looking forward to. And that's how you can sort of build a very basic, and again, this is, I call this basic even though it has so much of code, because there's a lot of innovation that you can do. You can do chain of thought reasoning around it. You can make it much more complex, and you can make things very fast here as well. But you can see the capability that from just sending each file and asking a question, you were able to build a system where you can just send a question and get the answer, citing everything so that you know it's not hallucinating. And at the same time, it's doing cross-modal reasoning, which is what you see here when things are going. And it has intelligence because of embeddings to know where the answer is available. Again, across different modalities, not just with text, across different modalities. Um, I'm gonna show you a couple of more examples so that you get the idea of how things are working. So let's take another question, which is how does Gemini 1.5 long context work with video, images, and all? And again, you can see that it went through, answered the thing, and this time it figured out that this answer is available in a product launch video, which makes sense, right? Like you're asking a very specific question, which looks like might be available in product launch video. But the funny thing is, you didn't pass any of those things. You didn't mention any of these things in the prompt, right? It figured out that all of the questions that you're asking is available in a product launch video. And that's exactly what it did. It gave you the answer. It exactly told you which videos are those. So if you see, the first one is problem solving across lines of code. These are again the open YouTube videos of Gemini, and things like that. Now let's ask a question which you were asking before, where we are actually sending the PDF, right? Which, what are the key achievements for Google Cloud in terms of training LLMs using their TPUs? Again, I'm not sending anything. And it was able to figure this out pretty much. And you can see that the citation, if you look into the citation, it's very impressive that it figured out that this is available in a blog post, and it doesn't require. So it's not that it always figures out audio, video. It's very intelligent that, oh, this, I don't need to go to any video or audio because all of this is available in a text, and it gave you that answer. The last one is the same question that we asked when we were giving the same PDF. This time again, you can see that it gave you the correct answer, 56.06. And again, you can see that it was figuring out all of this from the different data that you have. So it figured out where the answer is, and it finally gave you the correct answer. With that, I'll take a pause. Or in fact, that's all I wanted to cover for today. Now let's take questions. And I would prefer if you can just raise your hand and ask questions. That way it'll be easier. Back to you.
Thank you, Lavi, for your wonderful session. So, anybody would like to ask any question?
Feel free to raise your hand and ask the question directly. It's quite confusing to see on the chat. Neelam is asking, how can we undo a bad feed? What do you mean by bad feed? Sorry, can you extend that question? I see one interesting question. Sorry if I mispronounced your name, Etine. Um, the question is, with pre-processing PDFs, you extract images, charts, text, and tables. To what extent do you lose context for each item? The text might elaborate on the chart or even the footnotes. Amazing question. That I think is a very interesting question. So let me sort of quickly share my screen one more time to address this question. So you're absolutely right. This is one of the big problems with RAG also in general, which is you do lose some context. Sometimes the context might be available in a different page altogether, or maybe you extract a table, but the context of the table was before. The reason I want to show you this is, and this is where the beauty of 1 million, 2 million context comes into picture, right? And tell me if this sort of makes sense, right? If you remember how we were doing the application PDF thing, this is where I said that it makes a lot of sense to send the whole PDF as an image, because this way Gemini will have the context across. So it's not like you're sending just the text or just the image, you're sending the whole page as an image as is. In the MRAG that I showed you, I'm essentially doing the same thing. If you actually go to the code, just to quickly show you that, sorry. If you see this function, when I know which pages the information is, I'm not sending individual text or image or table. I'm actually sending the whole page. So I cut those pages from the PDF. I make a final PDF of, let's say, 5 pages where the answer is, and I send all of them together as a separate application PDF, which is what I show here. Now, this is a very easy way where you will still intact all the context. So you're not losing the context. In fact, you can say, hey, why just send 5 when I can send pages one before, one after, and everything? And again, this is happening because you do have a good context window, right? So this way you can sort of address that problem to a larger extent. It doesn't mean it's 100% solved, but it's a much bigger and better way to sort of address that. I hope that makes sense. Yuri is asking, will you maintain? Yes, so that's my responsibility. I will be maintaining these notebooks. We are also sort of transitioning this notebook into, in fact, this is a good time for me to talk about this. We do have a repo which is maintained by my team. It has wonderful assets around Gemini. If you go to, and I'll share this link as well, real quick. If you want to know many other things what Gemini can do from a cloud perspective, this repo will be very helpful to all of you. So as of now, I'm maintaining the notebooks, and then soon the notebooks will transition into the main repo, which is, again, you will know this when you'll see my no my this. I will make a note saying this. The new versions are available there. This one is properly maintained with all the updates and everything, so you should be able to get to this at some point. All right, any other questions?
I can see Naga is raising hand. So, Naga, I'm unmuting you. You can ask your question.
Yep. Thank you for the session. And so, how difficult it is to have this, instead of having the API based, Gemini is having, API based calls. How difficult to have that in-house development of that same models. Suppose you have enterprise, if you want to have that in Gemini in our enterprise, how difficult it is, or how easy or difficult, just
So let me ask the question, or rephrase the question and tell me if this makes sense. So what you're asking is, I want to use Gemini, but I want to use this in the enterprise setting, and with that, there comes a lot of expectation from a security, compliance, and bunch of things, right? And your question is, A, how can I do that with Gemini? And B, is it easy as you show it, or is there something extra that I need to do? Is that correct now?
yeah, I want to have the same setup like Gemini setup in my enterprise. So I don't want to
You
have,
want to locally host the model
yeah,
and
correct.
not do the, yeah, so I think that's not possible at this point. You can't have local setup of Gemini. You would have to use enterprise APIs inside the Vertex AI, which comes with all the enterprise safety and all of those things, compliance, everything. A lot of our customers who have the same thing use that. So um, what I would suggest, if you're still sort of in a area where you're like, no, 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 I want something local, I would say then explore Gemma or Llama 3.1 models. They are really great in that sense. They are not multimodal, so you would not be able to do what I just showed you. But given how innovation is happening, maybe we'll have multimodal models open source so that you can deploy them in your ecosystem.
Yeah, okay, thank you. Yeah.
I see more hands, I think. Go ahead, Dobra, and then Anand can go next.
Can you hear me? Hi.
Yes, I can hear you.
Yeah, okay. First of all, thank you very much. This was very, very interesting. I have a
Thank
question. I mean, just for my understanding, you said that basically if you present the whole PDF, including the text and tables and everything all at once as a PDF file, Gemini basically has more contextual information than if you do this in the pre-processing step. But actually, what does Gemini do with the PDF internally? Uh, I don't know if you can really explain this, because I cannot see what else it can do, but basically try to extract these individual pieces of information and try to correlate them. But this is exactly what you were doing, like in your pre-processing steps. Is my question
Right.
clear?
Sorry. Go ahead, sir.
No. I just wanted to ask if you understood the question. I'm not sure that.
Let me rephrase and see if I can if it makes sense. So essentially, you're asking that, okay, I see that when you pass a PDF as an image, Gemini is able to extract whatever I'm asking. How is it doing that? Because
Yeah.
when you give a text, it makes sense that sure, it's sort of doing that reasoning and getting that. But how is it able to do extraction without giving the text, but from the image? Correct.
Yeah. I mean, basically, without internally separating the text, like from the tables, from the images, and somehow connecting them. Because you
Right.
have to
Absolutely.
tokenize everything, and basically you have a mixture of the text, you have images and everything. So what kind of tokens do you produce? And then, okay, but
Yes.
okay, thank you.
No, no. Go ahead.
No, I'm finished. Okay, thank you.
Okay. Perfect. Again, it's a very interesting question, very important question, and this is one of the question which a lot of developers and a lot of people ask, which is, we see the power of multimodal, but we don't understand how all of this is sort of happening, like what's happening in the back. What I'm going to also do in the meantime is I'm going to share the paper of Gemini. it's very interesting to go through the paper because this exactly answers the question that you have. In fact, you can just upload it in Gemini or Chat GPT and ask the exact same question, and it'll give you the detailed answer of how it is doing it. But a short answer here is Gemini, because it has been trained from the very starting in a multimodal way. So what they do is, at the training level, is imagine you have an image where they have done the OCR extraction. That's like a data preparation stage, and this is what they're training the model to, saying, hey, I'm going to give you, let's say, millions of images, and OCR extracted, properly tagged, like, oh, you see this chart, here's what it means, here's what the chart means, here's how to correlate charts with these values and things like that. So what Google did was they built this huge data set of charts, images, tables, and all of that. And then they fed this to the model, saying, if you were given an image, this is how you're supposed to respond. So it's just the power of the data set and the training that they have done, which is why we are able to do exactly what we just showed you, that when you put a PDF in a single page, it knows how to deal with the question, because we have, in the training phase, we have exactly sent these kinds of data sets in the training. I hope it answers at high level, but if you want to go in too much detail of it, I would highly request check out the paper. It exactly talks about all the tokenizations and how does the whole trading sort of works in that aspect. Does it answer you, Dora? You can let me know on the chat, I think, if you're not there. Anand, do you want to go next?
Okay, hi Lavi. Thank you.
Yes.
It was indeed a great session. Okay, thank you very much for that.
Thank you.
My question was about yeah, I mean it was similar to the first question, right? There are a lot of reasons. There are many customers or many enterprise does not want to go for an API based LLM. I mean, I do not want to interact with the base of externally hosted LLMs, but in
Mhm.
they're looking for even if it is a smaller LLM size, if it is able to perform a very specific task, I mean, it could be very good for local enterprise. Okay, the one thing is. Uh, there are a lot of security reasons. I mean, I know even if Google says that we have a very security, there are a lot of customers or enterprise will still not be, I mean, in a position to share their classified documents with any other enterprise. Okay, it might be
Right.
due to GDPR or any other or any government's perspective data sharing laws as well. Okay, so if I want to have a very small, I mean, I can use the Hugging Face Gamma 229 billion token model in-house, but how much, I mean, I use that basically, but the inference time and tuning time is, I mean, it's a lot more. I mean, it
Yeah.
needs a lot of data, it needs a lot of training time as well as the hardware. Okay, but
Right.
we were very far away from achieving our goals, to be frank. Okay, how can I mean, is there any way we can reach, and let's say we were just trying to analyze the PDF. Okay, PDF of just 2 to 3 MB files. Okay, if that is my goal, okay, with my smaller LLM, will I be able to achieve that with inference time within a second or 2 seconds? Because API are basically a real time, right? And if it takes more than 5 seconds, it's 5 seconds or maybe 10 seconds. Sometimes it doesn't make sense. Okay, is there any such kind of local LLM I can build? Okay, which can infer and get back the results within few seconds? Can we do that? Even fine tuning the model itself as well as hardware bumping. Is there any possibility that we can do?
There's a lot of questions that you asked, so I'm gonna, as far as I remember, I'll try to address all. The thing is, again, there's a difference between what I showed. So if you are asking, can I do exactly the same thing in the local environment with open source model at this point, the answer is no, because we don't have very good comprehensive multimodal models at this point. We have one from Meta, which they recently published, but it's not very good compared to what you're seeing here. So the short answer is, right now you'll not be able to do exactly the same. What you can do, however, is the normal RAG, where you don't have audio, video, and all of that. It's just sort of PDF files and text files, where you would have to take care of all the extractions and all the tables and all of those things. Now, coming to the second part of the question is the fact is, okay, I do open source, but I still have issues with inference time and training times and all of that. If you want to do this locally, then you have to invest in the hardware and the software stack, which is, for example, we have VLLM, we have XLlama, we have llama.cpp. There's so many software stacks which optimizes the runtimes of the models, which optimizes the tunings of the model to a larger extent. But the answer is, if you're again asking that, hey, no, I have limited hardware in that I want to sort of make things faster, then I would say again the short answer is no, because then you would have to go at the very engineering level and then optimize your whole stack, which may not make sense in the larger scheme of things. So most of the answers are no in the immediate effect, but as the innovations are happening on, and maybe in 1 year down the line, you may have all the things that you just asked for, and you may be able to do all of this. Does that make sense? Okay. You can let me know. Okay, perfect. Evelyn, the last question. We'll take the last questions, and do try Pali Gemma as well. Dhruval is commenting. Pali Gemma can do the image part, not the video and the other. So you can try that as well. Thank you, Dhruval. Evelyn, you want to go next?
Hi, yeah. Thanks, Lavi, for your presentation.
Thank you.
I have well, I had two questions, but one of them, it seems that one of them was answered. It seems like you were saying that the images are converted into tokens by like through an ML step in which there's a model that is trained to map images to descriptions of those images. Is that accurate?
Yes, I mean high level, ground level. There's a lot of intricate details into it, but yes, at high level, it has been trained to do what we see on the front, which is it has been given so many pairs of, let's say, an image or a whole page, and somebody has tagged each and every. So somebody was also saying that, hey, wouldn't it be more error prone if you were to do this OCR version? But again, these data sets have been prepared, not all manually, but they have been validated manually. So they send the right, so it assumes that it'll do the correct extraction in that case. So yes, at high level, this is what is happening, that mapping.
Okay. Yeah. And my other question was about how much text content or like image or video content is 128,000 tokens.
Interesting. So if you actually open the second notebook, let me see if I can show you that. Let me share my screen one more time. You go to the second notebook, VAI one, at the top, you will see an image, and there you will actually see something very similar. So, for example, it tells you what is the max video that you can process, and this is 720p video. So, in 1 million context, you can process 1 hour of video, one at a time. So, audio would be 8.4 hours. PDF should be no greater than 30 MB. If you're sending images, it should be 3,000 images. 1080p in that sense. If you do 2 million, things are slightly different. And you can sort of, again, these keeps on changing as per the token and all. But you can get these information. You can click on the links I've given, and you'll get the live of that. Does that answer your question?
Yes, that's helpful.
Okay.
Thank you.
All right. Do we have any more questions? I see Anand's hand. Anand, do you want to go? or you've already asked the question and I'm seeing the hand again. I'm not sure. If you can speak, go ahead. Dhruval is saying, is there any hands-on guide on merging small language model for different modality either by Google? I am not aware. Shrikant, can someone share a link of notebook? Okay, I'll share that one more time. I think we have all the questions. I think we are good to go. I am on Twitter. If you have any questions, I'm not on any other social media. If you would want to reach out to me, feel free to send me a DM on Twitter, or just tag me if you have any questions. Dobra has one more question. Go ahead. I think you have access. Anna saying, so basically using the Hugging Face models may not make to production in enterprise for most time. No. So what I meant is at this point, that's the only way you have, because you cannot go to the cloud. So at this point, that's all you can do. And because the innovation is happening so fast, maybe you get something in that level, at level of big models. Like for example, Llama 3.1 for 405 billion model, which is now comparable to both GPT-4 and Gemini from a text perspective. So I foresee that maybe down the line, you'll have multimodal models as well. Dobra, do you have access now?
Yes, I do. Okay, I mean, I have a question which is not 100% related to this, but maybe you can point me to a publication. I actually come from the control system theory and everything where people use basically state space models, and lately in the literature people are talking about like an alternative to the transformer architecture, which is based on some kind of a state space models. I looked at some papers. Basically, I was not able to understand the definition of the states there. Do you have do you have a good understanding of this, or basically a good reference where these things are really described in detail? Because what I have seen, I simply didn't understand.
I'm not a super expert on the state space models, to be very honest. But one thing that I can point you to is, just like transform models, there's something called as Mamba architecture.
Yeah.
Right, so that has a lot of state space kind of innovation, so maybe that could be something that you can look into, and that's also considered to be the alternative to autoregressive like transformers. And also, again, I'm not too familiar with all of those things, but that is one thing that you can explore.
Yeah, I mean, I spent some time looking into this, but probably I have to spend more time. Okay, thank you very much. Thanks.
All right, thank you. I think with that we can stop the session. Thank you so much everyone for staying back, and like I said, reach out to me on Twitter if you have any questions. And up until then, see you next time if you ever get a session again.
Thank you, Lavi, for your wonderful session, and thank you for answering most of the question asked by our audience. And I hope everybody has got some insight and enjoyed this session. And before ending up, I encourage you all to post the summary about today's session so that we can get to know that yes, it was useful for you all. And when you post anything on LinkedIn, you can tag us on the same post. I have pinged all the links in a group chat. And by any chance, if you have missed any topic, anything, you can watch our recorded session afterwards. It will get uploaded on our YouTube channel, and the same link I have posted on in a group chat. So yeah, thank you all. Thank you for joining us today, and I hope to see you all soon in our upcoming session.
Thank you.